Hello and welcome to my channel. I am nxdx. Please, if you're new here, kindly subscribe to my channel. And if you have been watching my videos and you have not yet subscribed, please kindly subscribe for us to grow the mathematics community. In this lesson, we are going to prove the reduction formula for the integral of sine of x to the power n dx. Wow. Please, if you're new here, kindly subscribe. Now, let's do the proof in a very simple way. Now, the integral of sine exponent n of x dx can be written as the integral of sine exponent n minus 1 of x times sine of x dx. This is because sine of x to the power n minus 1 times sine of x is the same as sine of x exponent n minus 1 plus 1. And minus 1 plus 1 is the same as 0. So we have sine of x to the power n, which is the same as sine exponent n of x from the laws of exponents. Very, very simple as that. Because this one is the same as writing sine of x to the power n minus 1. So if I add n minus 1 to the 1 here, it will come back with this. Very simple as that. Now, let's move on. Here, we are going to use the integral by parts formula. If I have the integral u dv is equal to uv minus the integral du. So now, let's say that u equal to sine of x to the power n minus 1 and dv equals sine of x dx. Why are we choosing this? This is because this one is very simple for us to integrate than using this one. So, for the integral of this, we have u equal to sine of x to the power n minus 1. So, if we let t to equal to sine of x, then dt on dx is equal to cosine of x. And then it implies that u is equal to t exponent n minus 1. And du on dt equals n minus 1 times t to the power n minus 2. Subtract 1 from the power, you get this. And we have our du on dt to equal to n minus 1 times sine of x to the power n minus 2. Now, du on dx is equal to, we have our du on dt times dt on dx. So this implies that du on dx is equal to n minus 1 times sine to the power n minus 2 of x times cosine of x. And now we can say that du is equal to n minus 1 times sine exponent n minus 2 of x times cosine of x dx. So this is our du. And if we integrate dv, we get v. If we integrate sine of x dx, we get negative cosine of x. So let's put this into the formula. So we have the integral u, and this is our u. This is our u. And this is our dv. So if we combine these two, you get this. So integral sine exponent n of x dx is equal to uv. So we have u and we have v. So sine exponent n minus 1 of x times minus cosine of x will give us minus cosine of x times sine exponent n minus 1 of x minus the integral v, and this is the v. minus cosine of x times du, that is n minus 1 times sine of x to the power n minus 2 times cosine of x dx. Wow, that's good. Please kindly subscribe, leave your comments too. So this is the same as negative cosine of x times sine to the power n minus 1 of x plus, that is negative times negative, give us plus. Here n minus 1 is the constant, so we bring it out. So plus n minus 1 times the integral cosine of x times cosine of x will give us cosine squared of x times sine to the power n minus 2 of x dx. Now we know that sine squared of x plus cosine squared of x is equal to 1. So we have cosine squared of x is equal to 1 minus sine squared of x. Wow. So you put 1 minus sine squared of x in place of cosine squared of x. So you have negative cosine of x times sine exponent n minus 1 of x plus n minus 1 times the integral 1 minus sine squared of x times sine exponent n minus 2 of x dx. Then we expand. So let's do the expansion quickly. So here we are going to have minus cosine of x times sine exponent n minus 1 of x plus n minus 1 times the integral sine exponent n of x. Yes, it's negative, right? So let's put negative there. Plus sine exponent n minus 2 of x dx. Why are we getting this result? If I multiply sine exponent n minus 2 of x times 1, I'll get this. If I multiply sine exponent n minus 2 of x times this, let's see what we get. You have minus sine squared of x times sine to the power n minus 2 of x. So here what do? You have sine of x, sine of x. So you write sine of x. Remember to bring the negative to the power 2 plus n minus 2. Minus 2 and 2 go. So we will be left with negative into brackets sine of x to the power n, and that is even minus sine to the power n of x. That's why we are having this one here. So let's multiply through by the constant. So we are going to have minus cosine of x sine to the power n minus 1 of x. Then we multiply this by that, we have plus the integral, plus n minus 1 times the integral sine exponent n minus 2 of x dx minus n plus 1 times the integral sine to the power n of x dx is equal to the integral sine exponent n of x dx. That's what we are having. So we can group like terms. Yes, let's group like terms. Let's connect this part of the board. So here, if this one comes here, we're going to have the integral sine to the power n of x dx plus, it's n minus 1, it's not n plus 1. N minus 1 times the integral sine to the power n of x dx, and this will be equal to minus cosine of x times sine exponent n minus 1 of x plus n minus 1 times the integral sine to the power n minus 2 of x dx. So you can factorize the integral of sine to the power n of x out, dx out. So you have the integral sine to the power n of x dx into 1 plus n minus 1 equal to, so here, let's do it quickly. This one plus 1 minus 1 will be 0. So you get n multiplying this. So let's write it very simple. So we have n times the integral sine to the power n of x dx equal to, so that you can clean this one off. You factorize this one out. That's what we've done here. You'll be left with 1 plus n minus 1. Minus 1 plus 1 will give you 0, or 1 minus 1 will give you 0. So you'll be left with n multiplying this, and that is the n that I've written here. Okay, so this will give us minus cosine of x times sine exponent n minus 1 of x plus n minus 1 times the integral sine to the power n minus 2 of x dx. Then we divide through by the n. So here I have negative cosine of x times sine to the power n minus 1 of x divided by n plus n minus 1 divided by n times the integral sine to the power n minus 2 of x dx to be equal to the integral sine to the power n of x dx. Hence, proved in a very simple way. Please kindly like, share, subscribe, and leave your comments. Bye bye.